Good day everyone, my name is Mr. Ademujimi Adedotun and this class is brought to you by Isaac Humanitarian Foundation. So what we're looking at is simple harmonic motion. Simple harmonic motion. Simple harmonic motion. SHM. When you say motion, of course, we know what motion is. Motion has to do with change in position of a body with what? With time. When you talk about harmonic, harmonic here refers to what? To periodic. So when we say what SHM means what? Repeating period. Okay? Repeating period, that is fixed time, fixed period, fixed what? Fixed period, fixed period. Fixed period. This is fixed, okay? And this is still the same thing as what? As a periodic motion, okay? Periodic what? Periodic motion. So this can be called what? A periodic what? Periodic motion, okay? Periodic motion, or you call it what? Or you call it what? Oscillatory what? Oscillatory motion. Oscillatory motion. This is also known as oscillatory motion. Oscillatory motion, take note. All simple harmonic motions are what? Oscillatory motions. Yes, very correct. That all simple harmonic motions are what? Oscillatory motion. But all oscillatory motions are not simple harmonic motion. Okay? All SHM are oscillatory motion. Oscillatory motion. Yes. 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 All simple harmonic motion are oscillatory motion. Yes. And also, but all oscillatory motion, all oscillatory motion are simple harmonic motion. All oscillatory motion are simple harmonic motion. No. No. All oscillatory motions are not what? Simple harmonic motion. But all simple harmonic motions are what? Oscillatory motion. Example of simple harmonic motion. We talked about what? A loaded test tube suspended in what? In water. Loaded test tube suspended in water. Simple pendulum. Simple pendulum. The heartbeat. And what? A spiral spring loaded with what? With mass. Spiral spring loaded with mass. Loaded with what? With mass. The movement of this is in linear simple harmonic motion in a straight line, moving to and fro. Moving to and fro. So such body is in simple harmonic motion, SHM. Take note that all simple harmonic motion are oscillatory motion, but not all oscillatory motions are simple harmonic motion. Like your wave. A wave. Wave. You talk about wave, you say wave is a what? Transferring of what? Of disturbance. Transferring of what? Of disturbance. This is what? Is an oscillatory motion. Wave is what? Is an oscillatory what? Motion. But still, wave is not regarded as what? Simple harmonic motion. Okay? Wave is an oscillatory motion, yes, but wave is not what? Simple harmonic motion. Because when we talk about wave, we talk about what? Transferring of what? Of disturbance. Okay? Transferring of disturbance, but the medium itself does not what? Travels. Okay? That is based on wave. Okay? So example of oscillatory motion, that is not what simple harmonic motion is what? Wave. Take note of that. Okay? So that is that. So all simple harmonic motion are what? Oscillatory motion, and all periodic motions are what? Oscillatory motion. Yes, 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 correct. Correct. Okay? So let's take for instance that we have a spring. Okay? And a force is what is applied to this. In pulling this towards this side, there will be what? A conservative force or restoring force. A conservative force or restoring force. Opposing the what? The direction of what? Of the applied force. Opposing the direction of what? The applied force. Okay? So this will be the applied force towards the side, that is F. So we have what? The extension. The extension, that is the displacement. This will be displacement from where? From the equilibrium position or the mean position. So this is known as the mean position. Mean position. Okay? Or what? Equilibrium position. Equilibrium position. Mean position or equilibrium position. Okay? If you recall from where? From our equilibrium. From equilibrium, we know that what? For a body to be what? In equilibrium, meaning that what? The net force acting on that body must be equals to 0. Yes. Okay? So let's take for instance that we have this and there's a ball here. Okay? If this ball is partially what? Displayed and this towards this side also, it will always what? Relax at where? At the initial position. Okay? So what type of equilibrium is this very what? This is stable. This is stable what? Equilibrium. Stable equilibrium. So at this point, when force is what? Applied to this spring. Okay? This will always come back to what? To its equilibrium position, that is the mean position. With the help of what? Of restoring force or conservative force. So at this point, so this point is what we call what? A stable what? Stable equilibrium. And at that point, F will be equals to 0. Because in equilibrium, net force must be equals to 0. The equilibrium position, the mean position, take note. Okay? So when force is applied to this, towards the side, then we have what? Conservative force or restoring force will be what? Negative. That's negative. Towards the side. In this direction. Restoring force act what? Opposite. It is always opposite to what? To the applied force. Always opposite to what? To the applied force. Bringing this what? Spring to its equilibrium position or mean position. Okay? So we can apply the force towards the side too. Okay? So we have what? First, force applied. Force applied. Then we have what? Restoring force or conservative force. Restoring force or conservative force will be what? Positive. Take note. Is positive. Opposing it. Opposing it. Opposing it. So from here we can deduce that what? That F is equals to what? Minus Kx. Minus what? Minus Kx. Where K is known as what? The stiffness. Stiffness. Or you call it what? Force constant. Force what? Force constant. That was the force constant of what? Of the spring. While X is what? Extension. Or you call it what? Displacement. Displacement. Displacement from where? From the mean position. From the mean position. Please take note. From the mean position or from where? The equilibrium position. The main position or the equilibrium position. Okay, so this K is, this minus that is in negative sign is as a result of what? The direction of what? The restoring force or conservative what? Force, opposing the direction of what? The applied force. So that's why it's minus. Okay, so F equals to minus KF. So we can say that what? F is directly proportional to what? To X. F is directly proportional to what? To X. Meaning that force is always what? Directed towards what? The mean position. Always to the what? Mean position. Mean position or equilibrium position. Force is directly proportional to the displacement. To the displacement. Directly proportional to the displacement. Meaning that what? When there is what? Increasing what? Increasing extension, then you have to what? Once you increase the force applied, then you have increased what? The extension. That's the displacement. Once you increase what? The force applied to it, then you have what? Increase the what? The displacement. Displacement, and from there we know that F. So F is directly proportional to X. That is, force applied, the conservative force is proportional to what? To the displacement. And displacement is always measured from where? From the mean position or the equilibrium position. The mean position or from the equilibrium position. So we can have the graph of F versus what? Versus displacement. The graph of X versus what? Displacement. That's X. So we have it this way. This will be what? Force in Newton. X in what? In meter. So this will be what? The graph. This is how the graph will look like. So this will be the graph of what? The graph of F against what? Against displacement. Force against what? Displacement. Meaning that what? Once you increase the force, displacement will increase. Increase what? Double the force again. You have displacement what? Will increase. Triple the force. Displacement will what? Will increase. So this is what? Is directly what? Proportional to the displacement, which tells us what? The definition of what? Of simple harmonic motion. That's the definition of what? Simple harmonic motion. Take notes. That's the definition of simple harmonic motion. Force is directed towards where? The center. Always towards the center. And at the center, we have only mean position. F is equal to 0 from equilibrium. This is stable equilibrium. When the body is slightly or partially displaced, it tends to want to return to its initial position, to its normal position. Okay? So this is stable. Stable is equilibrium. So at this point, this is stable. And we know that equilibrium, the net force, that is equilibrium. When you say equilibrium, net force, that is F net, must be equal to 0. F net must be equal to 0. Okay? So we know that F is equal to minus Kx, where K is known as what? The force constant, and X is the displacement from the mean position. When you say displacement from the mean position, look at it. Okay? Back to our diagram. Back to this. At this point, don't forget that X will be equal to 0. Yes. Displacement is equal to 0. Then F is equal to 0 at the equilibrium. F equals to 0. Displacement equals to 0. Okay? Now, at this point too, we can say that what? The velocity will be maximum. Acceleration too will be equal to 0. Take note. Acceleration will be equal to 0 at this point. Velocity will be maximum. Maximum. When you have what? Spring, then you stretch it towards the side. then you release it. What happened? Then you have, it's moved like that. So there will be what? Greater what? Velocity at what? At the mean position. So velocity here will be what? Maximum. Will be maximum. Take note. Velocity will be maximum. Okay? So from here, we know that F is equals to minus kx, where k is what? Force constant or stiffness of what? Of this spring. X is the displacement. So when force is applied to this, stretching this to this point. So X is always measured from where? From the mean position, from the center, from the equilibrium position. So we have X from here. If this is the extreme position, this is also what? Extreme position. So at this point, displacement will be equal to what? Positive A. A is what? The amplitude. A is what? Amplitude. Amplitude is what? The maximum displacement from the equilibrium position. Amplitude is what? Maximum displacement from where? From equilibrium position. Maximum here tells us about what? The extreme position. The extreme what position. Okay? So at this point too, X will be equals to negative what? A. That's minus towards this side. Of course, you know you have your positive x-axis, negative x-axis. So it's negative. Since you are stretching this towards what? The length. So it's negative. Okay? Now, from here we know that force equals to this, which is directly proportional to the extension. We know that, also recall that F equals to NA. F equals to NA. F equals to this, F equals to this. So F equals to F. So we can have what? NA equals to minus KX. So we can have what? Acceleration to be equals to minus K upon mx. Yes, dividing both sides by what? By m. That's the mass of the particle or mass of the object. Okay? So we know that, but what? But omega square is equal to what? K upon n. Take note. That omega is equal to what? This is called omega. That's the name of the symbol. Omega. Omega squared equals to K upon what? N. So from here, so anywhere we see K upon N, so we can replace this with what? Omega squared. So we can have, therefore, acceleration equals to what? Minus omega squared x. Take note. Minus omega square what? X. Acceleration equals to minus omega square what? Square x. Where x is what? The displacement from where? From the main position or from the equilibrium position. Okay? So look at this again. What would now be the maximum acceleration? When we say maximum acceleration, we know that acceleration will be maximum at where? At the extreme position. Acceleration will be maximum at where? At the extreme position. This is the extreme position. Okay? So at the extreme position here, acceleration will be maximum. Take note. At the extreme position here, acceleration will be what? Maximum. Then, when you have what? A spring, then we apply force, okay, to the extreme end, extreme position here, or you stretch it to the what? Right or left, we have the extreme position, okay. So at this point, we have displacement to be equal to 0, then F net equals to 0 at the equilibrium position or the main position, okay. F will be equal to 0 also, then here, when you stretch this towards the side, At the extreme position, acceleration here will be equal to maximum. We'll be having what? Maximum acceleration. Then you release the what? The spring. You see that what? Acceleration will move towards what? The center. There will be increase in what? In the acceleration. Increase in acceleration. Then what will happen to what? Decrease. Decrease in what? In acceleration. Yes. Because the acceleration will be what? Maximum at the extreme position here. Then you release it. Then it will be moving gradually, decreasing, decreasing. As the acceleration is decreasing, there will be what? Increase in what? In velocity. Yes. There will be what? Increase in velocity. As acceleration is reducing, velocity will be what? Increasing. That's the rule. Incrementing what in acceleration, we think about decreasing this. Increasing what? In acceleration, decreasing this. Decrease in acceleration, increase in the velocity. So once the acceleration is reducing, the velocity will what? Will increasing. Once the velocity gets to what? To the mean position there, or the equilibrium position, what happens to the velocity? Velocity will be what? Will be maximum. Velocity will be maximum here. Then acceleration will be maximum here. Okay? Because there will be what? And this when we have maximum acceleration. Once you release this, what will happen? Velocity will be what? Increasing. Once it gets to what? To the center, velocity will be maximum. Then acceleration will be what? Acceleration will be equal to 0. Okay? So, in order to get what? Maximum acceleration, we need 2 points. We have 2 extreme positions, right? 2 extreme positions. That is, x will be equal to what? Plus or minus a. X, that is displacement. When you say a means what? Amplitude. It means amplitude. And amplitude is what? Maximum displacement from the equilibrium position or the mean position. Okay? So, at where? The extreme position. Extreme position, we have what? Acceleration. Displacement to be equal to plus or minus a. So, we can have what? Maximum acceleration to be equals to minus omega squared. So if we replace this with what? With minus a. So we have what? We have minus times minus. That will give us plus. So we can have omega square what? Omega square a. Okay? So we can say what? Magnitude of what? Of maximum acceleration is omega square what? Omega square a. Please take notes. Omega square what? Omega square a. Omega square a. That is the maximum acceleration. Maximum acceleration. Maximum acceleration. Then what is the graph of maximum acceleration? Before that, you can say what? We can deduce that what? Acceleration is proportional to what? To the displacement. That is, acceleration is what? Is directly proportional to what? To the displacement. Okay? Then we know that also that force is also what? Directly proportional to what? To the displacement. So these are the 2 definitions of what? Of simple harmonic motion. So a simple harmonic motion is the to and fro motion or a periodic motion in which what? The acceleration is what? Is proportional or directly proportional what? To the displacement. And the force is always directed towards where? Towards the mean position or the equilibrium what? Position. Okay? So we have the graph to be, this is the graph of acceleration versus what? Versus displacement. So this is displacement, this is acceleration. So it's just going to be what? A linear graph. Increasing acceleration, increasing this, increases. Okay? So that is acceleration. So the maximum acceleration is equals to this. Thank you and God bless you.